In this video, we will review how to simplify square roots. So I just want to quickly review the parts of a square root before we start to simplify them. So first, remember that the number that is out in front of the square root, so it's not underneath the root itself, is called the coefficient. Then you have what's called your radical sign. So the square root symbol is also known as a radical symbol, so just keep that in mind. The number that is underneath the square root is called the radicand, and then everything together, the coefficient, the radical sign, and the radicand, all together form what is called a radical. So this whole video is going to be about how we simplify radicals. So by definition, a square root is fully simplified when the number under the root, so for example, say we had the square root of 10 and the square root of 45, okay? So a square root is fully simplified when the number underneath the root will have no perfect square factors. So that means that the number underneath the root is not divisible by a perfect square. Now, in order to figure that out, we need to know what the perfect squares are. Remember, the numbers that are perfect squares are numbers that can be perfectly square rooted and produce an actual integer. So for example, our perfect squares would be when 1 is squared, so 1, when 2 is squared, which is 4, 3 is squared, which is 9, 4 is squared, which is 16, and if we keep up with that pattern, it would be 25, 36, 49, 81, 100, 121, 144, and you can keep going if you would like. But you need to know all of the perfect squares from 1 to 144. That's essentially 1 squared through 12 squared. So all of these numbers can be square rooted and produce an integer. The square root of 1 is 1, the square root of 4 is 2, the square root of 9 is 3, so on and so forth. So if we look at a square root, so here we see the square root of 10. 10 is perfectly simplified because it is not divisible by a perfect square other than 1, because everything is divisible by 1. It's not divisible by 9, it's not divisible by 4, so 10 is a perfectly simplified square root. Now if we look at 45, 45 is divisible by 9, so this one would be not fully simplified yet because it is in fact divisible by a perfect square, and we'll have to do something in order to simplify it further. So when we look at a square root and we're going to simplify it, we always start off by looking at whether or not it is divisible by any of the perfect squares that we know. So you can start simply by just taking 200 and dividing it by all of the perfect squares if you want to figure out what it's divisible by. We don't include 1 because everything is divisible by 1, but if you take 200 and if you divide it by the perfect squares that you see, and if it produces a nice even number, that means that it has a perfect square factor and it needs to be simplified further. Now, if you were to go through all of these numbers, you would find that 200 is divisible by 4, 25, and 100. So because it's divisible by those 3, we are going to need to simplify it further. And it truly doesn't matter which one you pick. It's whatever is easiest for you. So I'm going to start with 25. As I said, you can pick 4, 25, or 100 because it's going to be the same process. But you need to pick one of the numbers that it is divisible by. Now if I take 200 and divide it by 25, I end up with 8. So I know that 8 times 25 gives me 200. So I'm going to rewrite this square root as 8 times 25. And then because of the way that square roots work and the product property of radicals, I can split this up into the square root of 8 times the square root of 25. And then from here, because 25 is a perfect square, I can think, okay, well, the square root of 25, what does that equal? Well, the square root of 25 equals a regular 5, because 5 squared is 25. So what I can do here is I can rewrite this radical, put the 5 in front as its coefficient, and say I have 5 square roots of 8. So by noticing that 200 was divisible by 25, I split it up into a multiplication problem, and then from there evaluated the square root of a perfect square. Now what we always have to do here is we always have to stop and check this number under the root again, because sometimes it's going to take multiple simplifications in order to get this square root fully simplified. So here I need to again take a look at all the perfect squares, and I notice that 8 is divisible by 4, and because of that, this square root here is not fully simplified. So I'm going to need to simplify it further. Now I know that 8 is divisible by 4, so I'm going to leave the 5 out in front and split the 8 up into the square root of 4 and the square root of 2. So then we can use the product property of radicals here. And then I know that the square root of 4 is 2 without a radical. So this becomes 5 times square root of 4 is 2, and then the square root of 2 stays in our radical. So we end up with 10 square roots of 2. And then from here, I know that that's fully simplified because 2 is not divisible by a perfect square other than 1. So let's do 2 more examples together here. I can see that 117 is the number underneath my radical, so what I'm looking for are the numbers that 117 is divisible by that are perfect squares. And if I go through and divide 117 by all of my perfect squares, I find that 117 is divisible by 9, because 9 times 13 gives me 117. So I can rewrite this as the square root of 9 times 13, which then I can split up into 2 roots, the square root of 9 times the square root of 13. Well, the square root of 9 is 3, so I end up with 3 times the square root of 13, and then I notice that 13 is not divisible by another perfect square, so I know that it is fully simplified. Now if I look over at 192, and I divide 192 by the perfect squares that I see, I know that 192 is divisible by 64, 16, and 4. Now if you're looking for a way to make this process a bit more quickly, always rewrite it using the largest perfect square factor that you can find. So here we know that 64 times 3 gives us 192. So we take 192 and rewrite it as the square root of 64 times 3. So it becomes the square root of 64 times the square root of 3. Well, the square root of 64 is 8 without a root. And then we have the square root of 3, and 3 is not divisible by any perfect squares other than 1. So we know that that is fully simplified. The last thing we need to talk about is the difference between exact and approximate answers. And in our class, the expectation will be that you will always provide me with an exact answer. So an exact answer is in the form of a simplified square root. So for example, with this particular problem, we have the square root of 112. Well, that can be broken up into 16 times 7 if I divide it by the perfect squares. And then from here I can break it up into the square root of 16 times the square root of 7. The square root of 16 is 4 with no root. So my exact answer here is a simplified square root. And the reason this is an exact answer is because we are doing no decimal rounding. Now, if we were to find the approximate answer is going to be a decimal that is typically rounded. It's approximate, it's close, but it's not exact. So if we were to plug the square root of 112 into our calculator, we would find that that is approximately 10.58 rounded to 2 decimal points. So in this class, you will be expected to write exact answers. I will not be accepting the approximate decimal representations.